So today we're going to be talking about modeling means. Now this is a slight detour from what we were talking about before. We just pointed out two big problems with standardization, and we had no solution for those problems. However, we're going to need these tools and techniques in order to solve this, and we will solve it just next time. However, again, this detour will be necessary. So modeling means. Let's go back to the basics. So let's say we have some sort of treatment. In this case, it is a doctor. So a treatment that is a doctor. I'm going to add one more variable up here, actually, and this will be a confounder. So we're going to be interested as well in a specific confounder, which will be white blood cell count. So you can see how this might be relevant. As always, we are interested in a population. So let's say we sample people from the United States. So we've got a little person in a bubble. So that will represent the United States population. Okay, and we are interested in the outcome of number of days sick. So number of days sick. So this will be just y. Now, we can measure all of these, right? We can go ahead and we can get a sample from the United States and get all of this data here. However, again, white blood cell count is a continuous number. It's a very large number, imaginably. I'm not going to sort of state my lack of medical knowledge here, but white blood cell count is some sort of number. So we're not sure how we can get the average causal effect. So in this case, I'm looking for something a little bit different. I'm looking for something I'm going to call y hat, which is a predicted value. So this is not a causal value. This is a predicted value for the number of days sick that you'll be based on whether you went to the doctor and your white blood cell count. So y hat is a function of whether you went to the doctor and your white blood cell count. Now, there are many types of functions that we can use here. So there's a field called machine learning that talks a lot about these functions and properties of these functions and properties these functions have under various data sets. There's quite a lot of material here, and perhaps at one point in time, I'll go ahead and put stuff like that up. In addition, at a later point in time, I'm actually going to be, I teach an introduction to machine learning class over at the University of San Francisco. So if anyone's interested in that, you can go ahead and sort of send me your information. I can sign you up, but I'll be posting those lectures at some point or another. The only thing that this modeling requires is that we have some sample from our population. And this sample is generally, hopefully, a random sample. A random sample from our population of, hopefully, size really big N. So size big N. So this is the only thing we need for this modeling assumption to work. Now, the model that we're going to be using today is sort of the simplest jack-of-all-trades model. We're going to be using something called linear regression. Linear regression. Okay, so what is linear regression? Now, I could probably do 30 videos just on linear regression. It is a complicated, well, not super complicated, but it is a well thought out model. There's a lot of research behind it. However, there's a lot of people who have done videos on linear regression versus no one who has done videos on causal inference that I think in a good way. So I'll leave that to other people. I'll include some links below. However, I will give you a two-liner on linear regression. So here's my sort of two-liner on linear regression. So let's say we are looking at data points. So we are looking at data points such that people did not go to the doctor. So these are people that did not go to the doctor. So I can go ahead and have number of days that they were sick on the y-axis. So this is number of days that they were sick on the y-axis. And I can go ahead and have white blood cell count on the x-axis. And then I can go ahead and plot these points. So for example, we might assume that with a low white blood cell count, there might be a high number of days that people might get sick. And we might have lots and lots of samples that sort of show this trend. So as we get a higher and higher white blood cell count, we get fewer and fewer days sick. There's, of course, some variance in our estimate. What linear regression will allow us to do is it will allow us to, for any white blood cell count, so for example, a white blood cell count right here, it will give us a prediction as to the number of days sick a person will be if they had not seen the doctor. So, what linear regression will tend to do, let me use a nice color for this. I'll just go ahead and use white. What linear regression will tend to do is it will tend to fit a line of best fit through the data. So it will fit a line of best fit through the data, but perhaps your data is not linear, and so the line might look ridiculous. So what linear regression will do is it will fit a line through your data as such, and this line will allow you to say, hey, for any white blood cell count, I simply make a projection onto the line, and this will give me an estimate as to the number of days sick that a person would be. So I didn't need to have any person that had this exact white blood cell count in order to predict the number of days sick. Interesting, right? You might be getting good ideas as to how we can solve our previous standardization problem with modeling. Okay, so this is what linear regression is. I'm not going to say too much more about it. I am going to say one more thing. Linear regression gives us a model that will look something along like this. So it'll give us a model with parameters, beta, I'll give this beta 1, times our value of whether we were seeing the doctor or not, plus a beta 2 times the parameter of white blood cell count, so L. So it'll give us fitted values of beta 1 and beta 2. You can see that the relationship is linear because I'm simply multiplying whether they went to the doctor times something that is linear, a coefficient. And through machine learning, we'll actually go ahead and get these coefficients. Okay, so we know how to model means now. We know that linear regression is a good tool in order to model means. We know that modeling means that we'll be able to predict for any white blood cell count the number of days someone is sick based on the surrounding data. So what can we do with this? Okay, find out next time.